Hello viewers, welcome back. So today we're going to be covering halogens. So basically halogens are just the elements in group 7 on the periodic table. So this group, alright? So it contains fluorine, chlorine, bromine, iodine and astatine. So let's take a look at this figure over here. Over here it shows the electronic structure of each of the elements of the halogens. So over here, as we go down the group, we also notice that the atomic radii increases. Now why is this so? Chlorine has 3 electron shells, and bromine has 4, iodine has 5, and astatine has 6. So as you can see, as we go down the group, the number of electron shells increases. So therefore that increases the atomic radii as well. Now another thing to take note is that by looking at the structure over here, each of them are just 1 valence electron away from attaining a noble gas structure. Alright, so let's talk about the physical properties of halogens here. So halogens exist as diatomic elements, so that means chlorine exists like this, bromine exists like this. Alright, so they exist as simple molecular structures, so each of the atom in the halogens are bonded to another atom, their own atom, and it's by covalent bonds. So each of that molecule is then attracted to another molecule by weak van der Waals forces of attraction. So a thing to take note is that the larger the molecule, the stronger the van der Waals forces of attraction. Now why is this so? Because as you can see, larger the molecule, so as we go down the group, the more electron shells. And the more electron shells means there's more electrons. So the number of electrons actually increases the strength of the van der Waals forces of attraction. Now another physical property is that they get darker as they go down the group. So halogens are, as you can tell, colored compounds. So fluorine is a yellowish-green, pale yellowish-green gas. Chlorine is a yellowish-green gas. Bromine is a reddish-brown liquid. Iodine is a purplish solid. And astatine inferred to be black. And another physical property of halogens is that their physical state changes from gas to solid as we go down the group. Now, fluorine is a gas. Chlorine is a gas. Bromine is a very volatile liquid. Iodine is solid. Astatine is a solid. Now, from this we can infer that as we go down the group, because of their state at room temperature, we can say that their melting point or boiling point increases as well. And that's what we're going to be taking a look at. So now we're going to take a look at their melting and boiling points. So over here I have all the halogens except for fluorine. So this is their melting point. Now chlorine here has a negative 101.5 degrees Celsius. Bromine has negative 7.2 degrees Celsius. Iodine has 113.7 degrees Celsius, and astatine about 300 degrees Celsius. So as you can see, as we go down the group, the melting point or boiling point increases. Now why is this so? As we go down the group, as we have established before, the molecule gets bigger. So the van der Waals forces of attraction also increases in strength. So therefore, as the forces increase in strength, you therefore need more energy to overcome these van der Waals forces of attraction. So if more energy is required to overcome these forces, you therefore have a higher melting and boiling point. And that actually corresponds to what we have here. Now, like I said, let's take a look at chemical properties here. So as we go down the group in the halogens, the reactivity decreases. So fluorine compared to bromine, fluorine will have a higher reactivity. Alright, so let's take a look here. So over here I have fluorine, chlorine and bromine. These are their electronic structures. So over here you can see that fluorine has the least amount of electrons and bromine has the most, and also the most amount of electron shells. So why is it that fluorine has a higher reactivity than bromine? Now let's take a look here. The valence, like I said just now, these halogens just need 1 more valence electron to attain a noble gas structure, so therefore they have to attain it in their valence shell. If we compare fluorine to like bromine, from the nucleus to the valence shell, fluorine's distance is shorter when you compare it to like bromine to bromine shell. Yeah, so it's way longer. So because of the increase in electron shells as you go down the group, the valence shell would therefore be further away from the nucleus, and thus it will be harder for the nucleus to attract electrons from other atoms into your valence shell. So yeah, therefore their reactivity will decrease, and also the other shells inside will also shield the pull from the nucleus. So therefore fluorine will have a higher reactivity because it will be easier for fluorine to attract electrons. Alright, so other properties include what reactions that halogens would produce. So halogens react with metals to form ionic compounds. Now why is this so? Because halogens, right, they just need to gain the electrons, and what do metals do? They give away the electrons. So they're very good reducing agents. So this sodium over here, sodium will actually give away the electron to form sodium ion, cation, and chlorine would then gain that electron and form a chloride ion, and sodium ion and chloride ion will thus be bonded together by strong electrostatic forces of attraction to form a sodium chloride lattice with a whole bunch of others. Now halogens will also react with non-metals to form covalent compounds. So one example of this is chlorine gas and oxygen gas. You form a chlorine dioxide. So yeah, that's the kind of reactions they can form. So I hope this video helps. Thanks for watching.